3, this is section 1. Today we're going to look at a new concept known as functions. And functions are going to be an important concept for the remaining part of your mathematical career. So functions are just a new name for equations. Now, functions have a specific relationship between inputs and outputs. Inputs are those x values that you would put into an equation, and the outputs would be like your y values, the result of evaluating that expression for the given input. Now, a function is a relation that pairs each input with exactly one output. In other words, in terms of an equation, each x has only one y. All right, so let's jump into some examples here and learn to determine if a relation is a function. So a relation here is a set of ordered pairs, and what we are going to do is look to see that if each input, each x has only one y. So taking a look here, you got -3, 1. Your x is your first listed coordinate, and your y is your second. -3, 1, -2, 1, -1, 1, 0, 1, and 1, 1. Does each input have only one output? In other words, does each x have only one y? And here, we're going to say yes. Therefore, this relation is a function. Now, if you contrast that with the next one, in 1b, you see that we have an ordered pair of 1, 3, 2, 4, 3, 5, 1, 5, and 4, 6. This 1 is repeated in the x's. In other words, there is an x value that has two different y values. In other words, one input has two different outputs. So in this case, we're going to say no, this relation, these sets of ordered pairs, are not a function. Okay, one way to kind of remind yourself there is there should be no repeated x values. In example 1c, we have the ordered pair 0, 0, 2, 1, 4, 2, 6, 3, 8, 4, and 10, 5. This is just another way to look at a relation or sets of ordered pairs. If you want to write them out like we had them above, then you would write the ordered pairs just as I'm doing here. Okay, well, there are no repeated x values, and therefore we're going to say yes. This sets of ordered pairs here, this relation is a function. All right, let's check the next set of inputs and outputs. And again, this is just another way to list similar information. So these ordered pairs would be 2, -4. And then you have another arrow, 2, -6, 3, -6, and then 4, -8. So as we write out these relations, you can see that there is a repeated x value. And because there's a repeated x value, there is one input that has two outputs. So we're going to say nope, not a function. All right, now that's what determining a function would look like when you're given the sets of ordered pairs. What if we're given the graphed representation of those ordered pairs? How do we determine if it is a function or not? Well, one way to tell is to list out those ordered pairs. Remember, you're going to list your x coordinate first, then your y. So this first ordered pair would be 1 over and 2 up. And then you'd have 2 over and 3 up. And then you have 3 over and 4 up, so on and so forth. Well, you can see that each x here that's listed is going to be a 1, and then a 2, and then a 3, 4, 5, and 6. There are going to be no repeated x values. So here, we're going to say, yes, this graph represents a function. All right, let's contrast that with the graph of 2b. Let's just take two ordered pairs. Let's take this ordered pair here and this ordered pair. And those ordered pairs, if we were to write them out, would be 2 over and 2 up. And the other one would be 2 over and 4 up. Well, you can see that we have a repeated x value. And that repeated x value would imply that this is not a function. So this brings us to be able to summarize how to look at a graph quickly and determine if it's a function or not. And the way we do that is what's known as the vertical line test. And the vertical line test simply states that if I can draw a vertical line through any point in the graph and it only touches the graph in one point, then it will be a function. However, if I draw a vertical line through a point in the graph and it passes through 2 points, then that will not be a function. So if that vertical line test touches more than one point on any part of the graph, then you got to say that it is not a function. All right, so a few more terms and definitions. The domain of a function is the set of all possible input values. Now the input values, remember, are known as your x values. And the range of a function is the set of all possible output values, which are also your y values. So here in example 3, it simply says to determine the domain and range of a function represented by the graph. So if we take a look here at graph 3a, we see it's just a plotted points here. So to list the domain are really just to list the x values. So if I take a look here, this is list. This first point here to the top left corner has an x value of -3. So we're going to list that as -3, and we're going to list it in this open brace. And then the next x value looks like it's -1. The next x value looks like it's +1. And then finally we have +3. And we're going to close off our domain values with a closed brace. Let's do the same thing for the range. Now remember, the range are your y values. So go back to that first point and find out what the y value is. If you trace it over here to the y-axis, you'll see that that y value is +3. And then you have a +1. And then you're going to have a -1. And finally, for that last point here, you're going to have a -3. All right, and those are my range values, or my y values. Now, this is a discrete graph, and a discrete graph is just plotted points. That's different than our example 3b, which is a continuous graph. Now, a continuous graph, you can draw a continuous graph by not lifting your pencil off the paper. Whereas a discrete graph, you have to lift your pencil off to plot those points. So we're going to list our domain in a little bit of a different fashion. This is going to be known as interval fashion. Okay, the interval is going to include all the x values where that continuous line is drawn. So the way we do that is we kind of smush this graph along the x-axis. And that means I'm going to take the end points here and kind of push it down to the x-axis. And it's going to be all of my x values between -1 and +3. So I start off by listing my minimum value, -1. And that's going to be all my x's greater than or equal to that -1, but less than or equal to my maximum value of +3. All right, so that's writing my continuous domain. Let's find out what it looks like to write our continuous range. Remember, our range are our y values. So now we're going to smush this graph against the y-axis. So if I take the maximum point here and push it to the y-axis, it's going to be here at 2. And I'm going to take my minimum point and push it against the y-axis down here at -3. And because it's continuous, it's all the y values between my minimum and my maximum. So I'm going to start off by listing my minimum and say that that's less than or equal to my y values, because we're talking about range. And that has to be less than or equal to my maximum value, which is 2. All right, our final definitions for today are independent variable, and this is the variable that represents your inputs. It's just another way to state your x values. Your dependent variable is the variable that represents your output. And we say that the dependent variable depends on what your input is. In other words, y depends on x. All right, our last example for today, we got the average head circumference of a human at birth is 35 centimeters and increases by 2 centimeters each month during the first 3 months after birth. So does this situation represent a function? In other words, does each input, your inputs are going to be m number of months after birth, okay? Does that each input have exactly one output? The output is going to be c, the circumference of the baby's head after m months of birth. Okay, so we're going to say yes. Our independent variable, first of all, we listed here is m, the number of months. And dependent variable is going to be the head's circumference. And we're going to say yes, this is going to be a function, because each input will have exactly one output. All right, now a baby has a 2-month checkup. Find the domain and the range. Well, the domain is going to be our input at 2 months, and that is going to be equal to 2. And our output, which will be our range, will be that 35 plus 2 centimeters times the number of months after birth. So that baby's circumference of the circumference of that baby's head should be 35 plus 4, which is 39 centimeters.